Welcome to AI Frontiers, where we explore revolutionary breakthroughs in computer science and artificial intelligence. Today we're examining 10 groundbreaking papers from August 2025 that are reshaping our understanding of what's possible with AI. From simulation-based disease forecasting to collaborative intelligence systems, these advances represent paradigm shifts in causal reasoning, interpretable AI, and real-world problem-solving. Our spotlight focuses on the Mantis disease forecasting foundation model, a system that challenges everything we thought we knew about training AI for critical applications. Picture this scenario that seems impossible. A computer system trained exclusively on simulated disease data consistently outperforms teams of epidemiologists who spent months fine-tuning their models using actual pandemic data. This isn't theoretical research, it's happening right now. The system never encountered a single real-world outbreak during its training phase, yet it beats expert-tuned COVID-19 forecasting models that were specifically calibrated with real pandemic data. This represents a fundamental challenge to conventional wisdom about how AI systems should be trained for critical applications. We're witnessing AI's evolution from narrow, specialized tools to sophisticated systems capable of genuine reasoning and collaboration. These aren't just pattern recognition machines anymore. They're developing something remarkably close to intuition about cause and effect relationships. Modern AI systems can collaborate like jazz musicians, improvising complex pieces, working together to create solutions that exceed what any individual system could achieve. They can explain their reasoning step by step, walk through their decision-making processes, and even identify potential weaknesses in their own conclusions. This evolution is driving paradigm shifts across domains, from pandemic response to software debugging. The field of computer science artificial intelligence resembles a vast digital ecosystem. Imagine a rainforest where algorithms and data structures evolve at breakneck speed instead of biological organisms. At the forest floor lie fundamental algorithms and mathematical foundations, the decomposing computational leaves that nourish everything above. The understory contains specialized techniques like neural networks and graph algorithms, branching in countless directions. The canopy represents daily applications, recommendation systems, language models, and autonomous vehicles. At the emergent layer, reaching toward unprecedented capabilities, we find consciousness, creativity, and genuine understanding beginning to take shape. One of the most significant themes emerging from current research is what we call detective AI, systems that move beyond simple pattern recognition to understand causation. Traditional AI functions like a security camera that can spot a burglar, while detective AI operates like an investigator who pieces together the entire sequence of events, understanding motives, methods, and connections. This shift from correlation to causation appears across multiple domains, from understanding hydrogen bond formation in molecular simulations to diagnosing complex software system failures. The distinction is crucial for decision-making. Understanding that rain causes people to use umbrellas rather than the reverse correlation enables proper causal reasoning. Collaborative intelligence represents another revolutionary development. Multiple AI systems working together like members of a jazz ensemble, each contributing unique skills and perspectives to create something more sophisticated than any solo performance. These systems learn to debate with each other, vote on solutions, and teach one another, resulting in collective intelligence that exceeds the sum of individual parts. Research demonstrates that when multiple language models collaborate, with each system voting on solutions and weighting votes by confidence levels, collective performance improves by 16% over individual systems. This approach mirrors human problem-solving, where diverse teams with complementary expertise tackle challenges that would overwhelm individual experts. Interpretable AI addresses the critical need for systems that can explain their reasoning in ways humans can understand and trust. These aren't just transparent algorithms, they're genuine collaborative partners that function like brilliant colleagues. They provide correct answers while walking through their thinking processes, pointing out potential weaknesses in their reasoning, and explaining why they're confident in their conclusions. This interpretability is essential for critical applications in healthcare and finance, where understanding decision-making processes is as important as the decisions themselves. The most advanced systems are developing something remarkably similar to intuition and the ability to articulate their insights clearly. Current research has produced several key discoveries that are fundamentally reshaping artificial intelligence capabilities. Simulation-trained models now outperform expert systems trained on real-world data, challenging conventional training methodologies. Multi-AI collaboration consistently beats individual systems by significant margins, with 16% improvements in mathematical reasoning benchmarks. Hybrid symbolic-neural reasoning systems achieve cognitive flexibility by combining intuitive understanding with systematic logic. Multi-modal systems provide expert-level analysis across different data types simultaneously. Additionally, new graph reasoning frameworks handle structures 10 times larger than existing benchmarks, while achieving 50% improvements over massive-scale language models, using fewer computational resources. Our featured research, the Mantis Foundation model by Dudley and colleagues, represents the most paradigm-shifting work in our collection. This simulation-grounded disease forecasting system was trained entirely on over 400 million simulated outbreak days, never encountering real-world disease data during training. Despite this limitation, Mantis outperformed 39 expert-tuned models across 6 different diseases and beat all participants in the CDC's COVID-19 Forecast Hub. Most remarkably, the system generalizes to novel transmission mechanisms that were held out during training, suggesting it has learned fundamental principles of disease dynamics rather than memorizing specific patterns. The Mantis methodology demonstrates how simulation can capture real-world complexity through sophisticated design. The training encompassed diverse pathogens with different transmission mechanisms, from airborne spread like COVID-19 to vector-borne transmission like malaria. Various intervention strategies were modeled, including vaccination campaigns, social distancing measures, and travel restrictions. Critically, the simulations included realistic surveillance artifacts such as reporting delays and testing limitations that affect real-world disease monitoring systems. The mechanistically interpretable architecture allows users to understand not just predictions, but the underlying epidemiological principles driving those forecasts. Mantis has transformative implications for global health by democratizing access to advanced epidemiological modeling. The system provides accurate forecasts at 8-week horizons, essential for public health planning activities like vaccine distribution and hospital capacity management. By being ready for the next pandemic before it begins, Mantis addresses critical limitations revealed during COVID-19 when forecasting models had to be built from scratch. The foundation model approach makes sophisticated disease forecasting accessible to resource-limited regions that lack capacity to develop their own expert-tuned models. This methodology extends beyond disease forecasting to any domain where mechanistic understanding exists, but real-world training data is scarce. Looking toward future developments, we're standing at the digital frontier like explorers gazing at uncharted territory. Domain-specific foundation models are emerging that deeply understand particular fields, achieving superhuman performance by incorporating specialized knowledge and constraints. Hierarchical reasoning systems operate at multiple abstraction levels simultaneously, mirroring human cognitive flexibility. Practical deployment considerations focus on efficiency, robustness, and scalability for real-world applications. Human-AI collaborative partnerships are evolving beyond tool-use relationships toward genuine intellectual collaboration. These advances promise to democratize access to advanced AI capabilities across diverse applications and user communities. We're witnessing an intelligence revolution that transforms AI from simple tools into partners in human progress. The evolution from pattern recognition to causal understanding enables AI systems to reason about why things happen, not just identify that they occur. Collaborative systems consistently exceed individual capabilities through diverse expertise and collective decision-making processes. Simulation-based training revolutionizes critical applications by enabling sophisticated performance without extensive real-world data requirements. Interpretable AI creates genuine human-machine partnerships where systems can explain their reasoning and collaborate transparently. Join us as we continue exploring these frontiers of artificial intelligence and their implications for our technological future. This research synthesis demonstrates the collaborative potential of human and artificial intelligence working together. The synthesis process utilized Claude Sonnet 42025-0514 for content analysis and organization. Text-to-speech synthesis was powered by Deepgram technology to create natural-sounding narration. Image generation utilized OpenAI systems to create visual representations of complex concepts. Human expert review ensured technical accuracy and contextual appropriateness of the synthesized content. We acknowledge that some oversights may exist in this synthesis, and original research references are provided for detailed technical verification. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive-preprint-server.org, content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archive-preprint-server.org.